In this video, we'll be solving quadratics in Vertex form. First, there was x squared that was equal to 9, and whenever we solved it, what we would do is we would take the square root of both sides because a square root and a square cancel, and we'd be left with x equals plus or minus 3. Do not forget you will have two answers whenever you are taking the square root of a number. So you should get x equals 3 and you get x equals negative 3. You can either write them separate or together. Now, the same is going to apply anytime you have a quantity that is squared. This x minus 1 is trapped inside this parentheses. So you still need to get rid of the square first by taking the square root of both sides, and you'll get x minus 1 equals 3, and you'll get x minus 1 equals negative 3. Remember the plus or minus 3 that comes out? You're going to separate it into when it's equal to 3 and when it's equal to negative 3. So in this case, when you add 1, you will get 4. And in this case, when you add 1, you will get a negative 2. So in this case, the answers are 4 and negative 2. And just to show that it does work, if you were to plug 4 in, 4 minus 1 is 3. 3 squared does give you 9. If I plug in negative 2 minus 1 is negative 3. But the moment you take a negative 3 and you square it, you still get a positive 9. And that is why two different answers work. What some students do, please be very careful of. Do not do this. They add 1 to both sides and they just get plus or minus 4. Do not do that. You need to break up the plus or minus into two different equations in order to solve. So in this case, you cannot touch the 2 because the x minus 2 is trapped inside the square. You cannot take the square root until a square is by itself. So you first need to add 4 to both sides. You will get x minus 2 squared equals 4. Now you may take the square root. So you're going to take the square root of both sides and you'll get x minus 2 equals 2 and or x minus 2 equals a negative 2. Don't forget the square root of 4 is 2 and it's also a negative 2. So in this case, when I add 2, I will get a 4. In this case, when I add 2, I actually will get a 0. And again, you can plug it back in to see if it works. If I plug in 4, 4 minus 2 is 2, 2 squared is 4, and 4 minus 4 does give you 0. If I plug in 0, 0 minus 2 is negative 2. Negative 2 squared still gives me a 4, and 4 minus 4 gives me 0. Again, in this case, you have to look at this as one thing that you cannot touch yet. You first need to get rid of everything else before you mess with the square. So the first thing we need to do is go ahead and subtract 15. We will get 2 times x plus 5 squared equals a negative 18. And then we are going to divide both sides by 2 because don't forget the square needs to be by itself. It needs to be isolated. So I'm going to divide by 2 and I'll get x plus 5 squared equals a negative 9. Now that we have the square on the left-hand side and there's nothing else, we can now take the square root of both sides. When we do that, we'll get x plus 5 equals 3i, because don't forget the square root of 9 is 3, but the square root of a negative is i. And then we'll get x plus 5 equals a negative 3i. So whenever we solve for x, we're going to subtract 5, and we'll get negative 5 plus 3i as one answer. And then when we subtract 5 here, we'll get a negative 5 minus 3i. Or you could say it would be negative 5 plus or minus 3i would be the same thing as saying these two things separated. The 5's are still negative in both cases, but you would have a positive 3i and you would have the negative 3i. So to rewrite in Vertex form, in order to solve this is where we would go back to a previous section where we talk about the negative b over 2a. Don't forget you have a, b, c. So negative b over 2 times a would be a negative 2. That is our x value. And now to find the y value, we plug in negative 2 and we will get 4 minus 8 minus 7, which will give you negative 11. So to rewrite this into the form of x minus h squared plus k, a represents 1, h represents negative 2, and so that becomes a plus 2 because a minus and the negative 2 turn to a positive, and then negative 11. And now that we have this in Vertex form, we can now solve it. So to solve for this, before we can mess with the square, we're going to go ahead and first get rid of the 11. And now to get rid of the square, we will take the square root of both sides. And we'll get x plus 2 equals plus or minus the square root of 11. Now you can leave it like this, or you can split it into x plus 2 equals the square root of 11, and x plus 2 equals negative square root of 11. So when you subtract 2, you'll get negative 2 plus the square root of 11, or in this case, you'll get negative 2 minus the square root of 11. Or, to combine it, your answer would be negative 2 plus or minus the square root of 11. The plus or minus needs to stay with the square root. All you did was just subtract 2 on both sides. The height of a punted football can be modeled by this function, the horizontal distance in feet from the point of impact of the kicker's foot. Suppose the ball was not blocked and continued on its path. So you have some quadratic that's going to look roughly like this. This is the moment of impact. If the ball got kicked and then landed on the ground, what they're wanting to know is what is this distance from 0? What is the x value at this case of the 0? So to solve this, we're going to put it in a vertex form, which is negative b over 2a. So we will get negative 2 over 2 times a, which is going to give us a positive 12. Now we need to plug 12 back in. So you'll get negative 1/12, 12 squared, plus 2 times 12, plus 5, which gives negative 12, plus 24, plus 5, which will give us 17. So to rewrite this as a vertex, it would be a x minus 12 squared plus 17. And now we can actually solve it. We cannot mess with this yet, so we first need to subtract 17. And now we need to multiply by 12 because 12 is divided, so you got to multiply by the reciprocal. So multiply by a negative 12 and you will get 204. And now you would take the square root, since the square is now by itself. So take the square root of both sides. And you'll get x minus 12 equals plus or minus the square root of 204. However, this is a real world situation, so the negative is not going to come into play because you cannot have a negative length of down the football. So our answer is going to be adding 12 plus the square root of 204, which will give us 26.39 feet, and that is how far the ball will go when it lands on the ground.